Hi, I'm Queeny Dasgupta and I joined the PhD program in bioengineering in 2013. I graduated around early 2018, after which I went ahead to pursue a postdoc in the United States. I was in Dr. Don Ingber's lab at the Wyss Institute, where I worked on lung on chip systems that recapitulated radiation induced lung injury. After that, I moved to industry and I was at a startup called Systemic Bio, where I led several programs, and these were bioprinted vascularized organ on chip systems that were looking at drug induced toxicity, particularly vascular injury and immune toxicity. After that, I moved to my current position, which is at Sartorius. This is a principal scientist position where I lead the research on advanced cell models that include organoids, organoid on chips, and looks at how these human relevant models could be used to better drug development. My time at bioengineering was really rigorous and very, very rewarding. It helped me get a very strong foundation across disciplines, starting from biology to engineering. Research there taught me a lot of scientific rigor, discipline, and also humility, because there are things that you will know nothing about that you will learn for the first time in bioengineering. It also helped me take ownership of all my decisions and my learning. So, one of the things that I really figured, because people come from such diverse backgrounds, everybody's learning curve is absolutely not the same. So, it helped me set my pace and try to stick to it, even though, of course, there's ups and downs in it. Uh, One of the things that in during a PhD, a lot of days you will not be as motivated as you need to really be during a PhD, and then I think the specific advantage that the bioengineering um, program gives us is that it gives us this ecosystem and this community where even though you are not feeling 100%, you will run into someone or the other who will talk about their research and talk about how excited they are, and you will suddenly engage in this very long discussion about their work, and then at the end of it you realize why you were it reminds you of all the things that why you like research and why you are doing what you're doing. And even though this is not that much of a great day for you, but overall you appreciate why you're doing a PhD or a master's. So the courses offered by the bioengineering program are really great. Some of the courses that I wanted to mention, one of the courses was called Biology and Physiology of Engineers, if I remember correctly. And although I had a biology background, it did give me a new perspective towards looking at biology, and that was a great start to the course. And another course that I really liked, it was called the biological thermodynamics and transport phenomenon. So this was a course where I had taken thermodynamics and transport earlier of non-biological systems, but this course was something very different. And at the end of this course, the assignment was to read up a paper which to present a paper essentially, which talked about some kind of transport phenomenon by some kind of thermodynamics and transport phenomenon that happened in a biological system. So I remember presenting a paper which was about the transport involved in the cryopreservation of cells. As a biologist, this is a very routine thing that we do, where we add DMSO and freeze it to in liquid nitrogen. But really knowing the ins and out of why it matters and how the transport actually is controlled by this kind of controlled freezing is something that's it was really exciting to know, and that's something that I still appreciate about that course. Other than that, I did take a lot of courses outside the bioengineering program as well. Some of them related to polymers and biomaterials, because that was the primary focus of my research. And some of these courses actually had open book exams. So there was always this emphasis in the coursework for getting your basics right. So if the idea is that if your basics are right, you'll be able to solve the question paper. If you're not clear about them, then no book will help you really to get to the answers of the exam. The other thing that I really appreciated in our bioengineering program were the practicum courses that we had to take in the first two semesters. These were basically training for your practical hands-on training in your lab. And this was not just something that you did on the side. At the end of the semester, you actually had to present what you had learned, what you had done. And we did these small, almost like mini projects, which we had to present. So that was our first exposure to the lab that we were going to the labs we were going to work in, and also getting questions about our research and getting asked about why did you do this versus you could have done something else. Why would you do one certain procedure, use this procedure to get to this readout instead of doing something that's simpler, etc. So that's where you really learn to get the skills of answering questions about your research and why you are the best person to really defend what you have done. Some of the notable people that really influenced me in my journey, one of them was Professor Kaushik Chatterjee. He was my advisor during my PhD, and I worked with him very, very closely. And I think most of what I want to be as a researcher and scientist, a lot of it actually comes from him. He has this really perfect balance of getting regular updates from people, but also giving them a lot of room to innovate and learn, make their own mistakes, and really pick their path essentially during their PhD. So it was an absolute pleasure working with him. The other person that really influenced my journey was Dr. G.K. Anand Suresh, or Suresh as we called him. He was the chair of the department at that time. While he wasn't my advisor, but I did work with him closely on a lot of different bioengineering activities and projects. In general, he was a person who completely led by example all of the time, and that was something that I was always in awe of and wanted to learn from him. Other than that, he set a very different culture in our department and some things that a lot of people have already talked about, like he arranged these book discussions and student-led seminars, all of that. And in general, I think what he encouraged was that we become this community for each other. So I think that's something that he promoted and was very successful at, because we were always there for each other across different batches, etc. But it was really a great experience and environment in the department, and a lot of it has to go to Professor Suresh. So I have significantly diversified in terms of research from what I did in my PhD. In my PhD was about a lot of novel polymeric materials for biomedical applications, that like drug delivery and tissue engineering. But from there, I moved on to organ-on-chip research, and in general advanced cell models, so a lot of organized work, etc. But a lot of this work is interdisciplinary, and what has stayed with me from my bioengineering training is this interdisciplinary nature of the science and of the research. So while building these advanced cell-based models, I represent the toxicology or the biology function of the project, but in the same room we have a lot of different people from different backgrounds. Like we have material scientists, we have microfluidics engineers, we have 3D bioprinting folks, etc. But and sometimes when we are talking about, because usually the question comes from the biology that we need to replicate in our model, sometimes it's very difficult for everybody to speak the same language. But because of my background and my training in the bioengineering department, I feel like I can help translate and communicate these things better, just because I have been trained to always do that. So I think this is a life skill that it has taught me, and and has really come in useful as I've made progress in my work. In terms of advice, I have some very basic advice. That is, I would suggest that you um, start going into the lab as soon as possible. Once you start your PhD, the first two semesters are a lot of coursework. So even if you're not able to make it to the lab in the first semester, try going during the second semester. In my case, I only had classes on Tuesdays and Thursdays in my second semester, so I could go to the lab full time the rest of the week. So that really gave me an earlier start than a lot of others who had more coursework to do. So I would say that please pick your balance between lab and coursework early, by the second semester. The other thing I would say is about conferences. So if you identify some big conference in your field, then I would suggest that you go to these bigger conferences earlier in your PhD, because that really gives you an overview of the field. So this is almost like a few days crash course into the field. So you get an idea of what's going on, what's been done, what people are thinking about doing in the next 5 to 10 years. So that really helps you understand and organize your thoughts and gets you excited about the field. So that would be something that I suggest that you do early in your PhD. Towards the end of your PhD, when you have a thesis almost, go to more focused conferences, because these might be smaller, but what they will give you is that very good and useful feedback that you can bring back to your project and improve or develop on. So, and it also helps you make some really good connections in terms of in your field. So do that towards the end of your PhD. The other thing is that in interdisciplinary programs like these, you will always start with the comfort zone of yours. So if you're from biology, that would be your comfort zone. If you're from engineering, some branch of engineering will be your comfort zone. So please, and I say this very earnestly, please try to go into the other lab, learn from that, try to be as integral a part of the other lab which is not your current expertise, because that's the place that will make you uncomfortable. It will also be the place where you learn the most. So make sure you do that for yourself, because that's where you learn so much more. So in my PhD, one of my labs was a chemical engineering lab, and I had no connection to chemical engineering before that. So I went and I learned how to write equations for drug release and degradation kinetics, etc. So that's not something that I used right away after my PhD, but now, after so many years, when I actually do model informed drug development or I do toxicokinetics, it helps me really appreciate these models and to understand what parameters go into these models and what I could do to make it better. So that's been uh, that's been an understanding that has taken time, but it has also paid out in the end. So I, in the end, when you receive your PhD, it's not a doctor of bioengineering that you will receive. What you will be receiving is a doctor of philosophy. So make sure that that's what you're learning, that you learn how to think, how to uh, how to ask these questions, and how to go around solving these complex problems. So good luck to all of you, and thank you so much for your time. Bye.